Hello, this is Mr. Huber. In this lesson, we're going to look at the graphs of absolute value functions. What do we think the graph of y equals absolute value of x would look like? If we're ever not sure what a graph might look like, we can always make a table of values. So if we make a table of values with some x's and y's, we should have some negatives and some positives. Let's try negative 2, negative 1, 0, 1, and 2. If I plug a negative 2 in here for x, right, I'm plugging it in right there for x, I'm going to get y equals the absolute value of negative 2. So y equals the absolute value of negative 2 is just y equals a positive 2. I put a negative 1 in for x, y would equal a positive 1, 0. If I plug in a positive 1, the absolute value of that is still positive 1, and the absolute value of 2 would be positive 2. You can see we're always going to have positive y values because the absolute value is always going to be a positive number. So we're going to have a graph that looks like this, where for every x, the y value that goes with it is its positive value. So the graph would look like this. Okay. This is called the parent function for absolute value graphs. Y equals the absolute value of x, or f of x equals the absolute value of x, same thing. We're going to have these two branches of our graph right here on the right side and then here on the left. Those two branches of the graph will mirror each other on either side of what's called the axis of symmetry, which we'll get to in a second. It's going to be based off of knowing where the vertex is. The vertex is an important point. The vertex is that point of the V in the graph. For this graph, the vertex is at 0, 0. And if we look at the axis of symmetry for this graph, it's going to be the line that splits right down the middle of the graph. So the axis of symmetry is going to be this line vertically that goes right through the vertex. Axis of symmetry is it's symmetrical on both sides. The graph on this side is symmetrical to this side of the axis of symmetry. If we folded our graph along this line, it would fold right on top of itself. So the axis of symmetry is this line that goes straight down the middle of that graph. When we talk about transformations of graphs, that's how we change graphs. We adjust them. We move them in some way. A translation is just shifting a graph, sliding it to the left or right or up or down, horizontally and vertically. That shift is going to tell us where the vertex is. If you notice in this shifted red graph, we have a vertex right here that's moved over to some point h, k. That h and k match up with this h and k in our equation that we're going to use for absolute value graphs. Y equals the absolute value of x minus h and then plus k outside the absolute value. That tells us where the graph's shifting, left or right and up or down. We're going to have a vertex at the point h, k. Right? That h, k that we see right here in the vertex, okay, matches up with the h and the k here in our equation. We're going to see where we can use those to help us with the graphs. And our axis of symmetry is always going to be this line that goes right down through the middle of the graph. So it's going to come right down through here. That's our axis of symmetry. Okay? So the axis of symmetry right here is always going to be an equation that's x equals h. It's going to be x equals whatever the h value is, because that's where our graph is shifted over to. That's where the vertex will be, however we moved it left or right. Here we're going from 0, 0 over h and up k to get to that point. So the axis of symmetry again goes right down through the middle of the graph. It's that vertical line. It's always going to have an equation of x equals h, where h is that x value of the vertex. Let's see if we can identify the vertex and axis of symmetry in these equations. So h, k, remember, is going to be the vertex. So our vertex here is h, k. And remember, our absolute value equation is x minus h and then plus k. So minus h, the h value is 5, comma, the k value is 2. So our vertex would be at 5, 2, and the axis of symmetry would be x equals 5. We think the vertex and axis of symmetry for the next equation would be negative 2, because this is like minus a negative 2, right? If we talk about minus negative, here we're subtracting h, so we're subtracting an h value of negative 2 to get the plus 2. So we have -2, comma, -1 for our vertex, and our axis of symmetry would be x equals -2. Okay, so we can identify where that vertex would be the point of the V, and that axis of symmetry is always going to be the x value of the vertex. Back here, we saw in this equation this 3. That does not affect the vertexes or axis of symmetry. That's going to affect how narrow or wide our V is shaped when we graph. The other thing we'll look at in a graph is that A value. So when the A value is greater than 1, an absolute value greater than 1, it's a vertical stretch. Okay? It's going to be a graph that gets more narrow. Right? We can see here the graph gets more narrow when the A value is greater than 1. When it's less than 1, it's going to get wider. It's called a vertical shrink or a vertical compression. Okay? The graph's widening out. And when A is negative, we're going to get a flipped graph upside down. It's going to be V facing down when that A value is negative. Okay? And that A value is going to help us know the slope of each of the sides of the branch of that V. So when we draw out that V that goes like this, okay, the A value is going to tell us the slope of each of these. They're going to be the same, one positive, one negative. And we'll see that when we do the graphs. Okay? Again, if we get a graph with an A value that's absolute value is greater than 1, this V is going to be more narrow. If it's less than 1, the graph is going to widen out. Okay? And if it's negative, it's going to be flipped upside down. So we'll see that in some of the graphs we have coming up. So we're not even going to graph these out. We're just going to describe what we think would happen to them, what the transformation would look like. So in this first equation, we want to look for the A, H, and K values. This one just has an A value of 1/3. That absolute value is less than 1, so this graph is going to be a vertical shrink. Okay? A vertical shrink or compression. Okay? That means it's going to widen out. Okay? If I graphed the absolute value of x, let's say that was just absolute value of x, the 1/3 absolute value of x might look something more like this. Okay? That would be the 1/3 absolute value of x. Without getting exact numbers, that's what we mean by widening out, shrinking, compressing. In our next equation, we have an A value of 4. We have an H and a K value as well. So this graph is going to be a vertical stretch because it is an A value greater than 1. So it's going to be narrower than the absolute value of x graph. And it's going to be shifted or translated. Okay? Shifted. Not spelled entirely properly there. We can fix that. It's going to be shifted to the left 3 and up 8. How would I know that? Because it's going to have a vertex of -3, 8. That means the vertex is going to go from 0, 0 to -3, 8. The way we get that is we go to the left 3 and up 8. Okay? Our next equation is going to be a vertical stretch because, again, the absolute value of this is greater than 1. Absolute value of -2 is 2, which is greater than 1. That negative part does have an impact. It's going to be flipped upside down, and it's going to be shifted down 5. It's not moved left or right at all because there's nothing for an H value in here. It's just 0. So it's going to go down 5 because of this K value of -5. We're going to see how to do some graphing with these transformations here in a second. But first, let's search for a large number. Google, which we are all familiar with, comes from a mathematical term. It's a very, very large number. See if you can guess how many zeros are in the number Google. It's not spelled exactly either. A Google, OL on the end, is a 1 with 100 zeros after it. That number you see in front of you represents one Google, which is a very large number. Okay. And that's how they came up with the name for the company, Google. Let's make a table of values and graph this equation. The first thing we want to figure out is where's our vertex. That's very important. So the vertex is going to be at 2, 3. Okay. That helps us because when we graph that point, 2, 3, that's going to help us figure out what numbers to put into our table of values, what x and y values we're going to put in. We want to get some numbers to the left and right of this vertex. We want to get some x values going this way and this way so we can see what our v is going to look like on both sides. So we should plug in a -1 and 0, let's say, for x values. So we're going to use 0 and -1. We already know what happens at 2, 3. And then we're going to go to the other side, 3 and 4. So we'll get a couple numbers on either side of that x value where the vertex is. If I put a 0 into this equation, 0 minus 2 is -2. The absolute value, that is 2 plus 3, I'll get 5 for a y value. When I put a -1 in, again, I'm plugging these in up here into my equation. So I put in a -1, I'll get -1 minus 2. That's -3. The absolute value of that is 3, plus 3 is 6. So I'll get an absolute value, or number of 6. Should have put in a +1. So let's change that to a +1. Okay? If we change that to +1, then I'm going to get 1 minus 2 is -1. The absolute value of that is 1, plus 3 is 4. So I'm going to get here, when I put in a 1, I'll get a 4. Okay, -1 would have been further over to the left than I wanted to on my graph. I could graph that too, but I don't need to. If I put in a 3 minus 2 is 1, the absolute value of that is 1 plus 3, I get 4. And when I plug in a 4 minus 2 is 2, the absolute value is 2 plus 3 is 5. So I can see those would be my points I'm going to graph. So we can plot those points now. We'll get 1, 4, 0, 5, 3, 4, and 4, 5. And I could draw a graph then that goes through those points and makes a V going off to both sides. And the slope of this line here is 1, right? Rise 1, run 1. That's an A value of 1, right? There's no number in front of it, so there's a 1 there. And that A value is going to give us the slope of each of these branches. Okay? They should be symmetrical to each other, and this would be my axis of symmetry. My axis of symmetry would be x equals 2. So I made a table of values. I can see that graph looks generally like what I think it would. It's not a stretch or shrink. It's just shifted over 2 and up 3. Our parent graph, right, y equals just f of x, or excuse me, y equals absolute value of x would just look like this. Okay? So I've just taken this graph right here. I've shifted the whole thing over 2 and up 3. If I did that, it would lay right on top of that blue graph. So this is the absolute value of x, and this other one we graphed is absolute value of x minus 2 plus 3. Let's see some other equals here where we can make a table of values. Again, this one says f of x equals. That's the same as y equals. Don't get confused by function notation. Okay? We're graphing a function. Let's figure out where the vertex is going to be. Okay? The vertex of this graph is going to be at the point -1, -4. Okay? So I'm going to go to -1, -4, and I know that point is going to be my vertex. Now we can make a table of values. So my table of values, I should have numbers on either side of -1. Right? I want to pick some numbers to both sides of -1. So -3 and -2. So let's do that. We'll put in -3, -2. -1 we already have down, and then 0 and 1. Just see what happens on both sides of the vertex. We want to make sure we know what happens with both branches of this V. Okay? So now, when I put a -3 into my equation, and I'm plugging it in right up here, I have -3 plus 1 is -2. Absolute value is 2 times 2 is 4, minus 4 is 0. So when I plug in a -2 for my x value, I get a when I plug in -3 for my x value, I get a y value of 0. So that'd be 0. Okay? When I plug in -2 into my equation, jumping ahead to that one now, and I plug in -2 plus 1 is -1. Absolute value is +1. Then times 2 is 2. Minus 4 is -2. Get -2. I already have -1 and -4. And when I plug in 0, I'll also get -2. I plug in 1, I'll get 0. Okay, so you can try those, make sure you're able to get those values. And I'm going to plot these points. -3, 0 right there. -2, -2 right here. 0, -2. And 1, 0. And then I connect these and I'm getting a graph that's more narrow than my typical y equals absolute value of x graph, because this 2 here is a vertical stretch. My graph normally would go out like this. It's being stretched vertically, more narrow. Okay? And it's being shifted to the left 1 and down 4. Right? Normally you would have a vertex at 0, 0. So I can see here my table of values, and this line here, the points plotted on it, and over here has a slope of up 2 over 1. Right? That's where this comes in. This is the slope, 2. So now we're going to start to hopefully graph these without having to make a table of values. We can just know where the vertex is, know the slope of each side, and be able to graph the line without having to make a whole table. So let's practice that, because that can help speed up the process considerably. In this one, we're just going to graph the equation. We don't necessarily need to make a table of values. Okay? So we do need to find the vertex. The vertex is going to be at -6, 0. Okay? There's no k value here, so it's just a 0. So we can plot the vertex at -6, 0. That will be right here. And now we're going to use a slope of 5 over 2. This tells me that the branch on the right side and left side has a slope of 5 over 2. So I'm going to go from this point, I'm going to go up 1, 2, 3, 4, 5, and then I'm going to go over 2. And I'm going to put a point right there. Up 5 and over 2. I can go up 5 more and over 2 more and get that next point if I want. And I can do the same on the other side now. I'm going to go up 5 and then left 2. So if I do that, I'll have a point on that left side of the branch that's going to look right there. And then if I went up 5 and over 2, it would be off my graph a little bit over here, and I could draw my graph. And I didn't make a table of values. I didn't need to. I just used my vertex and then the slope for the line that makes up each side of the V. And that's what my graph would look like. Okay? If you wanted to check it out, you could plug in -4 for x and see, right, if I plug in -4 for x, I should get a 5 for y if you want to check and make sure that it's looking right. But you can just use the vertex and then the slope of that graph to come up with the graph. Let's try one more here. Okay, so now we're going to see a vertex at 3, 6. So we go to 3, 6 and put our vertex right there. And then our a value here is -1. That means it's going to be going down, a v going down with a slope of 1. So it means down 1 and over 1. So down 1 and over 1, down 1 and over 1. We keep doing that a couple times. We make sure we know what each side of the v looks like. And we've got our absolute value graph that's shifted and then flipped upside down. It's shifted because the vertex has moved to a new location, and it's flipped upside down because we have a negative a value. Right? So again, we get comfortable with what these absolute value graphs look like, know how to describe them, understand how to get the vertex. That's the most important out of this. The axis of symmetry, recall, the axis of symmetry for a graph like this is this line that goes straight through the middle of the graph. In this case, it would be at x equals 3. That'd be the axis of symmetry as an equation for that line, x equals 3. And then the a value in front will help us know what the slope of these two branches are that make the v. All right, so we'll get a chance to practice those, get comfortable with the different aspects of these and how to use them for reading the equations and drawing the graphs.